Hello everyone, this is SIG Scheduling meeting April 21st. On the agenda we have one item so far, and it's about post-filter refactoring. I would like to talk briefly about this to get your feedback and input. So starting what kind of post-filter problems we have. We obviously have nested scheduling. Just by introducing podgroups, we have two levels at which we do scheduling. So technically, post-filter could be a part of every subcycle that happens. So today, post-filter performs actions within the phase. So it can only apply the proposed action. So like make a mutation of the cluster state so that the next scheduling cycle can see the effects once they are fully applied to the cluster. So post-filter should be able to identify an action that will unblock scheduling of a pod in the next scheduling cycle. So if we have a workload scheduling cycle when we try to schedule several pods. So we in fact scheduling several subcycles. So those subcycles should not have any side effect, because when we do simulation, we will repeat this process several times. So we in fact have two options. We can either allow those post-filter to execute, but do not apply the action to the physical cluster yet, just simulate the effect in memory. Or another option is to disable post-filters everywhere and in fact allow post-filter to run only on the top level, at the top level object, and in only one place. So this post-filter can do whatever it needs to do, considering the whole workload, and at the very end decide whether those actions should be applied or not. So I think we have those two alternatives, and workload-aware preemption is actually using the later. So we can have only one global post-filter, and we are debating what exactly this post-filter should do. But at the very end, this is the place in which the action will be eventually taken or not. So this is the current situation, and we also, the problem is that we also have other post-filters, and the one well known is a DRA plugin which needs to do some cleanup. So technically, we can either refactor it and make it global as well, so being executed only at the top level object, or we can try to let those post filters run in nested environment, but then we need to figure out how to delay the execution of those actions. So my proposal would be to start with defining abstract interface for action. And action could have three methods. One is do the simulation, undo in memory change, so undo the simulation, and finally commit or execute. This way, the framework could delay the framework, or even the last post filter could delay execution of all those actions, but it can collect them, it can apply them if it needs to, or do not apply if it does not want to. And this is something that we can do regardless whether we allow nested post filters or whether we have top-level post filter. The good argument is the simulation library that we are building. We are in fact introducing actions that the process which is leading simulation can apply or revert. So do simulation, undo the simulation. So this is something that we need anyway. I think we should abstract every action to something that can be later used in both places. So both post filters could emit action that needs to be applied to the cluster, and in simulation library that would be an input, the initial input to the simulation. And the simulation itself will obviously like perform the scheduling simulation and return some results. So this is something that I think we should start working from the beginning. So we probably will have to decide whether we want to allow nested post filters or one global. I think it's not decided yet. I think we need some analysis, what are pros and cons, but I think introducing action might be useful right now. One more comment about the future approach. So post filters, so the action that post filters propose could be already in a form of a completely minimal set of actions. So to unblock scheduling in the next cycle, or technically we could even allow to emit more actions, or even all possible actions that a given post filter can perform. And this way we could allow the framework to choose which of those actions is better to apply, because this way we could allow framework to apply actions from many different plugins and take subset of actions of one plugin and subset of actions of the second plugin. I think it's doable. I imagine how it could work. I maybe don't have to present it right now, but I think that's the direction in which post filters could evolve. So do you have any concerns or comments about that?
Dominic, when you say nested post filters, does it also mean that they somehow need to agree on a single solution, or is there any relation between those separate nested post filters?
That's a good question, because what actually this nested execution mean is that at the very top level there is a commander that executes scheduling of the top level group, and it actually like commands what sub cycles and executions needs to do. So in fact it could also like command whether we want to run nested post filters, when we want to execute them, maybe each time, maybe sometimes we run with post filters, sometimes without post filters. So this is in fact the scheduling, how can we call it? The top level scheduling algorithm should be able to control. Does that answer the question? Maybe that also answers the question whether we should run it post filters nested or not, maybe this is the place which should at which level we should decide whether to run the nested one or not. Not?
So Dominic, I didn't get the last part about multiple plugins producing
Future.
actions and framework somehow.
Yes. So
like picking some subset. Could you provide maybe some example here to help me understand?
Sure. So for instance, let's take the simulation library. So the commander of the simulation is in fact the commander of scheduling, but it does not have a control over how scheduling is performed. It can only like request scheduling of a given pods. So in a simulation, we need to provide a set of actions, that set of cluster mutations that will be taken into consideration in the simulation. And I think this is a good example because, like, let's say that this is Q, which is proposing a cluster mutation. So it's proposing which other plugins workloads to preempt. And it has two options. It can either provide the minimum set of actions that are necessary to make scheduling successful. But since Q does not know the scheduling algorithm, it does not know what is the super minimum set of actions. So in fact, Q might provide a bit wider set of actions. So it will, in the first iteration, it will try to provide this set of actions and see whether the scheduling works or not. In the next iteration, it will like modify the set of actions, cluster state modification, and try again the scheduling. So it will always have a little bit wider set of actions because it doesn't know which exactly action is unblocking scheduling. So
Okay, I see. So
if we allow that, then we can think about what scheduling could do next. And I think scheduler can, of course, try to schedule a workload, but also it can tell which action was consumed, which action was necessary, and which action was not necessary, because for instance, scheduler could revert this action and the workload still schedules. So the result of the simulation might be not only whether workload was scheduled or not, but also which of the provided actions were necessary. That is something that we can do in the future. It's not something that we need today, but it's in fact what we are discussing with Reprival in the VAP, to try to revert abstract action, which is today we will have only preemption action, and see whether workload still schedules or not. So I think we can do the same thing, but generalized to an action that can be applied or reverted in memory.
Okay, but do I understand correctly that in such case you would need like more rich interface than this generic do undo execute that you propose, right? Because then actually scheduler will need to understand what this action actually changes in order to like, be able to.
Why?
Because it is just generic method like do without any arguments, without returning anything, right? Then how can you tell whether this is enough, or like how we can compare like two actions?
Because like at the beginning, like scheduler, the simulation will accept all the actions that were provided. It will apply them in memory.
Mm-hmm.
And it will try to schedule a workload. And obviously, if it fails, then it doesn't make sense to apply it. There is no other action that could be applied. So once the workload was scheduled successfully, the framework can start like undoing all those actions. So like Reprival in in the workload our preemption algorithm, and try to schedule the workload again, either in place or try to find an alternative placement without some set of actions. So I think it could be generalized this way. And besides of returning whether the workload schedules, we could technically provide a list of actions which were not necessary.
Okay, I guess we can like take it offline given it's a future idea. So just like one more question. Do I understand correctly that action is on a pod level, right? Or it's broader?
No,
It can be...
no. So action is on a cluster level. Well, on a cluster, because each post filter, like plugin, produce an action which is not dependent on which level the post filter is executed.
Okay, so action can be technically something like deleting multiple pods or
so
like
action that. The most obvious action is preempt a given pod. So remove pod, add pod. So this is what.
But it can be single pod, it can be multiple pods, right? That's what you are saying.
Well, those will be multiple actions if you want to remove multiple pods.
So action per pod. Okay, so that was my
action per action. Yeah, the atomic action that can.
Okay, so maybe action per API call, all right, or something like that, or.
Well, you could apply, I think, a set of actions in one transaction and later revert the whole transaction. So revert the simulation, I would say.
Like in memory, right? But not in API server.
Yes, in memory, yeah. So you can probably, we probably want to group actions somehow, but basically I would think about this as action as a atomic action that can be executed. So another example is obviously the auto-scaling, and the action that can be applied is adding a node or removing a node. We could have, for instance, the array attachment. So the action would be to attach the array device to a given node, or I don't know, maybe attach it. Yes, probably to a given node. And any custom post filter plugin could define its own action. How to apply it in memory, how to revert it in memory, and how to execute it in the cluster state eventually. So I think the scheduler does not need to know what the action does. It will see the effect simulated in memory, or if you apply or if you revert, it will see the action is gone. Hey, Michał?
Yes, a comment from, so hello everyone, it's like the first time I'm actually joining this meeting, so just a quick context, I'm actually maintaining Q, and as we are now integrating or beginning the endeavor of integrating Q with WAS via the scheduler library, I'm interested in these changes. So one maybe comment is that recently there was a dog. You might already be aware of that, but if not, just let me tell you from Bartosz Reiman on the idea of how to use the scheduler library inside Q.
Yes, of course. Yeah.
And there we are solving like a very similar problem as you are telling, like this is the set of, let's say,
yes, of course.
But which may not be necessary. So this is what we are doing with the preempt and unpreempt functions. So as I understand,
and this is the comment that I posted on the document. So we probably should think about how to abstract those actions, and instead of like creating dedicated preempt unpreempt API interface, we could start using those actions. but I think it can be refactored afterwards. I don't think we have to do it today, especially because we don't have this action interface yet. So replacing the preempt and unpreempt with preempt action and with just one action, I think it could be either the refactoring or we can consider it from the very beginning.
And let me ask a question. So do you consider this just like refactoring, or you also expect some performance improvement by changing the concept of preempt, unpreempt pods into do action and reverse action?
Pure refactoring. The action will be exactly the same. Well, the difference, I think, is that each plugin could define its own set of actions. So the ones that we know are add and remove pod, and all plugins understand those actions. But I think if we have action abstraction, then each plugin would register to events that it knows. So it could register to action type add pod, remove pod, because it knows that it has to adjust its internal cycle state or its internal like snapshot. But it will allow us to define actions that are abstract from other plugins. For instance, if the effect of a given plugin applies only to one plugin, then others does not need to know and care about those. An example is the array plugin, which the resource claim allocation cleanup is an action that no other plugin would be interested in. That's roughly the idea. Yeah, unless you have a comment.
If there are no more questions, I can continue, like the one I started. So if this interface is defined as is here, right? So basically do something, undo something without scheduler understanding exactly what it's doing, then like how can you pick the optimal like subset of actions necessary to do something other than like trying all combinations?
Yes. So so we have exactly the same problem in preemption. And I think we have two phases in which we can do something to optimize the scheduling placement. In the first phase, which we typically, in the first phase, you can apply some set of cluster mutations and try to run the scheduling algorithm. And each time you modify the set of actions, the algorithm needs to take into considerations the actions that were performed and actions that were undone. So we can have something like a cost of an action. Each plugin can define what is the cost of the action, and for instance, we can like sort all the actions according to their cost. So obviously, scheduler will try to remove the most costly actions first and retry scheduling and check whether the workload schedules. If it succeeds, that means that those most costly actions are not needed.
But I think like greedy algorithm is not guaranteed to be optimal here, like going for actions that are cheaper in this order, right? Because if those are anything, then technically the best, like the cheapest outcome might be the most expensive action and the least expensive action, right? Like overall, it sounds like NP-hard problem.
Yeah,
the way you are defining
Yes,
here. And
yes,
so,
it is,
so
but
you won't get optimal results without actually checking all the combinations, which is in turn infeasible.
Technically, yes, but technically it's the same like with our scheduling. We have like almost the same problem.
But like if you have more information, then you can like optimize and you can apply some
Sure.
Yeah.
Sure. What is the zero case is when scheduler does not try to do anything, just applies all the actions that were given. And this is the current situation. So post-filter plugins propose only those actions which are the minimum possible set that can unblock scheduling. This is the current post-filter logic.
Mm-hmm.
And today, this is the role of the plugin to find this minimum set. But in fact, it has to solve exactly the same problem. Like what set of actions it needs to apply to make the pod schedulable. And what you are suggesting is that preemption plugins knows better how to apply those actions and reverse those actions than a generic algorithm which does not know what the action does. But I think the algorithm that we are envisioned for preemption works exactly the same for other mutations. I may be wrong, of course. You can probably try to find actions for which it's not true, but I claim that we could abstract this algorithm to abstract actions, and when we don't care what those actions do.
Okay, and
So
I understand like what you are saying is basically a future optimization where we might try to figure out how to like work on this list of actions, maybe try finding optimal subset, but like starting point is just applying all the actions that the post filter plugin return. That makes sense. But like the problem I see here is with this optimization, like in future, and even like with simple cases like gang scheduling, right, or like workload our preemption, right? So if you are saying the action is per resource, so for example, add node or delete pod, right?
Mm-hmm.
Then if we take into account the workload our preemption, right, and we say we shouldn't be preempting workloads partially, so I can either preempt the whole workload, right, or don't preempt it at all, then this will actually be a superset. Like there will be dependency between action, because if I have a workload composed of 10 pods, I have 10 actions, right? And I should either apply all of them or none of them.
Well, not necessarily. Like the action that the plugin emits is to either preempt pod or preempt pod group. And this
so
this
action
is
is not
something
per resource.
that may result from the policy you are talking about.
Okay, I see. So
so
I think it would be good to like better understand the like semantics here of the action, right? Like I think we are understanding more and more from the examples you're giving. But like the other potential problem now, if we have like more like consistency will be a problem, right? In general, the more complex structure we have with these actions here, it's even a problem right now, right? With just what we have in scheduler, because API server doesn't give you any way to do transaction across resources. But this problem gets bigger when you have like more complex set of actions that you want to apply atomically, right? And potentially
no. There is no requirement that they need to be applied atomically.
But like I mean, like you can like do undo them in memory, and that can be like fully transactional. But then you want to execute something, right? And if it only like partially applies, then it gets like tricky to make sure like the scheduler actually reconciles that in eventually. So
sure, this is exactly how it looks today. So the action that post filters execute can succeed or can fail, and this is why we have the following scheduling cycle, which is basically waiting until all those actions are fully applied. So it's waiting until cluster state reaches the simulated state. And if something happens, like for instance, there was another pod or another workload that has higher priority and took the resources that you were trying to use, then the next time you are reconsidering the waiting workload, the one that preempted initially, this workload does not schedule anymore, because it will see a higher priority workload who took the resources this workload is waiting for. So this is one case when the scheduling cycle needs to decide that it needs to find a different placement. But
yes, but my point was like it works right now because we I would say it's still relatively simple, right? But we have like more dependencies in the future. The example you gave, like you have pods with resource claims, right? And then as a part of the action, you only delete the resource claim, but don't delete the pod. Then it might get like trickier to make sure like this reconciles.
So probably we need.
But like that's a problem anyway, probably. But my point is like it's easier to reason about this when it's like less generic and more concrete. And like for example, it's only responsibility
generic,
of a single like the array plugin, right?
Sure. Generic like vision is something that we may go into that direction, and we probably need to abstract the nomination concept to follow this path. So what nomination does, this is, if you want to preempt a pod, you nominate your preemptor to use the space that was freed by preempted workload. And probably we need to have exactly the same kind of nomination for other actions. So for resource claim, you have to like somehow reserve them. You are doing that in memory already in scheduler, but we need to have nomination not only inside scheduler but also in API server, so that no other. The nomination in memory, in scheduler memory, is the most important, I think. The nomination in API server is only to avoid races in case someone else might need a resource that was waiting for preemptor. But I think the most important is to have it in scheduler memory.
Michał, you have a hand?
So I have a question. Will there be some kind of API so that we can avoid doing the same work, like determining the minimal set of minimal in quotes, because as you said, it's NP problem, but we have some heuristics, so that basically we avoid applying the similar set of heuristics both at the queue level and Kubernetes scheduler level, so that we can say in queue that, okay, but I will take responsibility of determining the set.
So that's the idea of the future evolution, because the algorithm that we have currently in post-filter plugin could be moved to the simulation, to the framework itself. So assuming that this algorithm works, can work on abstract action, moving it to the framework would make sense, because Q would be able to provide a maximum set of actions. Okay, maybe not maximum, the wider set of actions, and scheduler could tell like which one were used and which one were not used. And this process can work in several iterations. And this is what the simulation should be about. So you should, at the beginning, you should provide it the set of the cheapest actions that you think should enable scheduling, and see whether it works. If it doesn't work, you are repeating this process and providing a different set of mutations that maybe are more costly, maybe they are simply different, but you are reacting in few iterations, you are generating a different set of mutations that scheduler should consider. So this way we can first try the cheapest actions possible. So for instance, preempt only workloads which does not violate PDB budget. And if it doesn't work, then in the second iteration, you provide all workloads which violate the budget. So with this mechanism, we can control like how invasive or disruptive the placement will be. So
okay, so maybe in queue, what we do, we also take into account, let's say, quotas. So for example, for us, it's less disruptive to preempt someone else's team's workloads, for example, if we run within our quota. So they are like, because they are kind of borrowing, so they always need to be prepared for getting preempted. So this could be more justified to preempt them.
Exactly. So in fact, we don't have to do it on the simulation side. It's probably the role of the commander to propose the actions in such a like order to drive into the most optimal, to drive to the less disruptive placement possible. So you received back the score of the placement, and you receive back the cost of the actions that has to be applied technically. So so you can decide whether to continue the simulation and try a different combination of actions, or you can stop right now because you feel like this is the optimal minimum that you have reached, the local minimum or local maximum. Local minimum in terms of the cost of the mutations, and local maximum in terms of how good the placement is. Roman, I think you were next.
Yeah, and you think all these actions need to be generated ahead of time and suggested to the scheduler as a multi-choice set of actions, or something that is more iterative, like let's like try one strategy first, like the cheapest one, and then if it works, then fine, it's the cheapest, it's probably the best. But then if it doesn't, then maybe I will fall back to a different strategy. I will evict more running workloads or pods. It will be more expensive, but I want to look for this strategy or set of actions only if the first option failed, because in a large enough cluster, there might be like multiple combinations and options. It's almost endless.
Exactly. So in fact, the commander of the simulation decides in which order the actions should be proposed. Set of actions should be proposed, and the algorithm of how to go driving to the optimal placement will be the role of the commander, not role of the scheduler. And this is where Q can like use its own logic based on its own criteria, but use the scheduling capabilities to use the scheduler logic to just schedule, not pick what is the best action to perform. So eventually we would like to refactor post-filter themselves to do the same thing. So post-filter could work not only in one iteration like it is today. So today it can propose only one set of actions or give up. But post-filters could repeat this process the same way like Q is repeating it. So in the second iteration, it can provide the more disruptive actions than they propose in the first iteration. But that's again like future like possible evolution of post-filter.
It also means that Q needs to keep track of what it already tried in the past and what it can do next, and also like to make a decision of what to do if the state of the cluster change in the meantime.
Yes.
Like,
so
to
we
go
assume
back.
that everything happens in a consistent cluster state, because this is the only way you can assure the simulation makes sense. And the reasoning that you are doing, it's based on the one cluster snapshot. And this is something that simulation already should provide. Simulation API. I'm not sure, Matt or Michał.
Yeah, I'm not sure here. I will just go, given I started already. So, two questions. So I would say right now postfilter does two things. So one is like applying those cluster mutations. So let's keep it concrete. So one thing is basically preempting pods, and the other is nominating
Preemptor.
nodes for the preemptor. So are you proposing we use this action interface for both, or only for preempting pods?
We will have to abstract somehow nomination concept to allow
differently than through the action interface.
It probably would. I'm not sure, because what we nominate is we nominate a pod to a
node.
To a node. I'm not sure how exactly we should generalize it, but I feel that this is something that we probably should do, because the scheduler itself should not like use in memory even use the resources that are pending to be freed up. Maybe this is the concept of resources waiting for free up, that we have already a customer for them. So don't use them for anything else. I haven't thought like that far. The thing that comes to my mind, like we could technically apply all those actions, keep those actions being applied in memory all the time. Simply, we need to wait for this to happen. So for instance, if we have node scale up, we are providing node in memory, and scheduler, after the preemption was committed, the scale up was committed, it will see this node in memory, but it will know that this node does not exist yet. So it cannot schedule a pod there, because this node has to be first provisioned. When it's provisioned, then it unblocks the action. I don't know. I'm just hand waving here.
Okay, and my second question is like going to the first point, and you said we have two alternatives, like where to execute, or like when to execute postfilter.
Yeah.
One is at the top level, and that seems like kind of obvious to me.
Yeah.
Because if we are to execute it at like lower levels, right, then we are potentially like we are either duplicating some work, or we can have some dependencies between some like entities below, right?
Yes.
An example is like if we have a workload that consists of two pod groups that are both gangs, and if we're running postfilter for like both of them, right, because neither of them fits, then technically the first postfilter may say to schedule the first gang, I need to evict pod A, and the second post group says the same, right?
Exactly the same feeling like you. I think it should be enough to have top level one only, but on the other hand, the problem is pretty complex, and I think the scheduling algorithm itself has to somehow balance at which level to execute postfilter. I don't know.
My question is like,
that's In any case, if we assuming that we introduce delayed application of action, we can do both. We can either let the post filter to be executed at each level and just collect the actions they produced without applying them on the cluster state. Or we can decide to execute it on top level only and simply have those actions in hand.
Okay, but the question, like in this example that I brought earlier, so inside the post filter, we still need to do some simulation, right, and apply those actions at least like temporarily on some snapshot.
So currently, yes.
Currently, yes, and like with your proposal, don't we need to do it as well?
Yeah. If we
some decisions might like affect the future decisions, right? So
if we move the logic outside, technically, post filter would just emit possible actions.
But my point is like to generate those possible actions, right? It also needs to like do some simulation and apply something.
Why? No. It just knows like what it can do. Like.
So if you have like post filter for a simple pod group, like that is a gang. So how would you implement that? Like to just like how would it know like what actions to emit without like doing like some simulation?
It has to run nested post filters inside each of the pod. So on the pod level, it will be like.
But even at pod level, we are already like doing simulation, right? To do post filter.
To find potential victims?
Yes.
So to define potential victims, you are like basically going through all pods and check which are lower priority than X. So no simulation is needed here, I think.
But we are like retrieving, right, to keep it optimal, like reduce.
Yeah. So this retrieval would be exactly the part of the framework algorithm. So the post filter eventually would just emit the possible actions that it can perform. If it can return the wider set, it does not have to do any simulation. And everything would be handled in this generic algorithm on the framework level.
Okay, but then I would really be interested to see this algorithm because I think
of course.
I see a way like to implement it in a performant way, like what you are proposing here.
Yeah, hopefully we don't have to do it now, but
I guess we have now because that's not about like future optimization. It's about like keeping the performance. It's about like not introducing regression in the performance area, right? Basically ensuring like we are not making it worse than the current preemption performance.
Yes, I agree. Yeah, we can take it offline. I think we don't have enough time to analyze it. Michał?
Yes, so I have additional comment to probably something related to what Roman was saying. I think there is a room for optimization because what Q is doing essentially when proposing the actions, we start with those like the least disruptive and incrementally build on top of them. So we have kind of internally in Q like a lazy generator that tries to first preempt one least important workload, whatever least means in terms of queue, and then extend to the second, third, and so on. But it's always like in the first phase, it's incremental expansion of the set of workloads. And then in the second phase, we do like contraction. So basically try to find which of the decisions were maybe unnecessary.
Sure.
Yeah.
So I think that this contraction could be done on the scheduler level, on the simulation level.
Yeah, but I'm also talking more about the first phase because it's at least currently in Q, and I think this is the most common use case when we have, let's say, in the commander, the lazy generator, that it's incremental, so that we may also try to think in scheduler how to optimize at least this use case where this build up of the actions is incremental rather than like completely different each time.
So yes, as I said, we have two phases of reverting the possible actions. The one phase in when reverting an action will impact placement, will impact scheduling. So after reverting a change, the scheduling algorithm should find a different placement of a workload, and this is something which drives the scheduler decision. But the second phase is when the scheduler already decided where to place a workload, and it can try to revert those actions without changing the preemptor placement anymore. And in this phase, this is simply a technical analysis. It can be completely iterative, and this is what our workload preemption algorithm does. So it reverts the actions without changing the scheduled work preemptor placement. So this is something that the simulation can return in effect. It does not have to find what is the best actions to apply, but it can just tell you, I scheduled the workload this way, and those actions were not needed. So we have to distinguish the actions that we perform before finding a placement and actions that we try to revert after finding a placement. And in the first phase is something that I think Q should do. So try to find the least disruptive set of proposed actions and see how it impacts scheduling. And the second part, after the scheduling was done, just technically go through the actions and decide which were not needed. And this way we can compare the cost, we can generate the cost of the simulation simply by summing up the costs of the actions that were used compared to unused. Roman or Matt?
I actually wanted to comment on what Matt, you raised this concern about performance, and one thing that comes to my head is that if you have a big enough cluster with multiple choices, with multiple combinations and different strategies, it's probably more related to the implementation step, but something to think about is that the scheduler probably wants to evaluate and attempt all the different strategies that are possible. But at the same time, the cluster state can change. So for example, you're looking for available resources based on the existing snapshot, but there is some workload that finished running and freed some resources.
Of course, yeah.
And
yes.
And it's like a sensitive decision, because you maybe you don't want to start from scratch every time a pod completes, because it might simply not be enough, and you don't want to go back to the to try all the options that you already exhausted.
So I think when we talk about simulations which are asynchronous, because if we consider, well, okay, every simulation is asynchronous because the cluster state changes happen no matter what we do. They don't depend on scheduler. So I think at the end of the simulation, we could do something. This is again something that we can do in the future. We could apply all the changes that happen to the cluster in the meantime and see whether the simulation still holds. I think this is something that we could do to make the simulation to decide whether it's worth to pursue with the simulation decision or the action that have changed in the meantime, like break it. So I think there are some things we can optimize that, but I wouldn't like worry too much about this at the moment because this is something that we already have anyway. It's already how queue works. We are running out of time. I would try to like write it down and publish it. I think what's important is to figure out what exactly we need to do in 137 release. We don't hear you. You're muted. Yeah. So I would try to like collect what we should do in 137 or not. So if there are no any other questions, but you have hand raised, but I think. Okay, so I think that's it. So thank you, everyone. Bye.
Thanks.
Thank you. Bye-bye.
Thanks.